Okay, welcome to the video for 2.4 part 1, real zeros of polynomial functions. Your objective is I will be able to calculate the real zeros of higher degree polynomials. Now, before we get there, this part 1 is just a bunch of different skills and things we need to know to get to the point where we can calculate the real zeros of higher degree polynomials. So first off, a little review on synthetic division. I'm giving you some steps here, but if you have, as long as you are dividing by a term that looks like x minus c, then you can use synthetic division. So what needs to happen here is we're going to divide these guys right here. So I need to find the zero of our divisor. So that's going to be 2. Put it in a little box, and then you're going to write the coefficients of the dividends next to that. So we have 2, we have -3, we have 5, we have -1. Let's make sure that all of our terms are represented. So we have x to the power of 4, x to the power of 3, x to the power of 2. So that means we need to get that in there. So we're going to put in a 0 for x to the power of 2. Then we have 5 and then -1. All right, draw in a line. And all you do is you bring the first one down. Like I said, the steps are over here. But we're just going to bring the first number down. Multiply. 2 times 2 is 4. Put that over here. Combine these, we get 1. 1 times 2 is 2. Combine these, we get 2. 2 times 2 is 4. Combine these, we get 9. 2 times 9 is 18. And we combine these and we get 17 here. So what did we come up with here? This last number is our remainder. Now, to write this function that we've come up with, we need to start with 9 as the constant and then work to the left. So this is a positive 9. This would be 2x to the power of 1. This would be 1x to the power of 2. And then this would be 2x to the power of 3. Okay, moving on. So the remainder theorem, what is this saying here? So if polynomial f of x is divided by x minus k, then the remainder is r equals f of k. So let's take a look and see what that means here. So here's our function, f of x, and we're going to divide by x minus 2, so just like x minus k. What that means is I can just plug in the 0 for this and find out what the remainder is. So let's give that a try. We have f of, well, the 0, we'd want to make this a positive 2 equals, and now everywhere there's an x, I'm going to take it out and put in my positive 2. If we simplify this, our first term here becomes 32. Make sure you take 2, raise it to the 4th power, and then multiply it by 2. Our next term is 24. Our next term is 10. Minus 1, simplify all this, and you get 17. So, take a look here. It's the same remainder. And we did divide the same polynomial by the same divisor. Okay, that was the remainder theorem. Now we're going to talk about the factor theorem. So find the factors. First, we're going to explore this before we actually get into the theorem. So find the factors of 25. So our factors of 25 are 1, let's get a different color going here, 1, 5, and 25. Divide by one of the factors. What is the remainder? I'm just going to take 5 and divide it into 25. 5 goes into 25 5 times. 5 times 5 is 25. We subtract, we get 0. The remainder is 0. Divide by a non-factor, what is the remainder? Didn't really leave us a bunch of room here. So let's go, if we divide by 6, right? That is not a factor of 25. It's going to go in there 4 times. 4 times 6 is 24. We get 1. In this case, our remainder is 1/6. Okay, so what works for numbers, for integers, also works for polynomials. So a polynomial function, f of x, has a factor of x minus k if and only if f of k equals 0. So look at this example here. What is our k? Well, in this case, we're going to, this is our factor of this. So what is our k? Think about that first. What are we going to actually plug in? So k, and notice that this is negative here, so that means we actually have to change the sign. So it's the 0 when we pull it out. So k equals -4. All right, let's go ahead and plug that in. -4 equals 3 times -4 squared plus 7 times -4 minus 20. Let's see, -4 squared is 16 times 3 is 48. Then our 7 times a -4 is -28 minus 20. 48 minus 28 is 20. Minus 20 does in fact equal 0. So we did show that that's a factor. We could have also synthetically divided it. If we synthetically divide it, then we should end up with a 0 remainder. Off to the side here, go ahead and do that synthetic division using the steps above to practice it, and then return when you're ready. So go ahead and pause the video and return when you're ready and see my work. Okay, so here you see my synthetic division. I did end up with a remainder of 0 here and here. Okay, next we're going to look at some fundamental connections for polynomial functions. Okay, so if we have x equals c is a solution or root of the equation f of x. So what we're saying with all of these is if this is true, then all these other things are true. Or if any of these are true, then all of these other things are true. And just written like this, it might be a little confusing, but we're going to write it out below and it will hopefully make a little more sense. So we're saying that c is the solution of the equation of f of x. If this is true, when f of x is divided by x minus c, the remainder equals 0, right? So we take f of x, so the whole big long function, we divide by x minus c. We know that this c is a solution, so therefore our remainder will be 0. We also know that c is a 0 of the function. We know that c is an x-intercept, right? So let's say we have this function. We know that that would be c there. And lastly, we know that x minus c is a factor of f of x. All right, so to help that sink in your brain, we're told here, if 5 is a 0 of f of x, what is true? Use the fundamental connections to list 4 things that are true. So right away, what this is saying, if 5 is a 0 of f of x, c is a 0 of the function. So we don't need to list that one because we already have that one there. So let's start from the top and write it out. If 5 is a 0 of f of x, then x equals 5 is a solution of f of x. See if you can put the rest of them together. So you're going to do 2, but use what we have for this example 4 here. And then when you're ready, rejoin me and see if you made sense of this. Okay, hopefully this is what you came up with, but based on what they're giving us, f of x divided by x minus 5 must have a remainder of 0. Then 5 is an x-intercept of f of x. So no matter what our graph looks like here, we know that here it must intercept the x-axis. And then lastly, x minus 5 has to be a factor of the function. Since all of this is known because we know that 5 is a 0 of f of x. All right, so let's use that in a different type of problem down here. Use a graph to factor this function. So what we need here, or what we can use above, is that if c is an x-intercept, then x minus c is a factor. All right, so if we graph this guy, it looks like this. And so I can find my intercepts. I have one at -2, I have one at 2, and I have one at 8. So using that, so -2, 2, and 8, let's get this one out of the way here. We can see that we have x-intercepts at negative 2, 2, and 8. So we can use that to find a factorization, a linear factorization. So then we can say f of x equals, well, we just need to use this part now, x minus a negative 2 would be positive 2 times x minus 2 times x minus 8. All right, another way we can use this is like what we're going to do in example 5. So find the function that has a degree of 3 and has the zeros negative 3, negative 2, and 2. So we know that if c is a 0, then x minus c is a factor. Okay, and we're going to put this in standard form. Function, I'm going to write in standard form. So we would have our function x plus 3, x plus 2, and x minus 2. Now, a degree of 3 simply means that here we have our 3 x's. When we multiply them together, it's going to give us a degree of 3. If it was a degree of 4 or something else, we'd have to get another x in there. So that way it would multiply through and give us a higher degree. All right, so let's go ahead and multiply this. And I'm going to show you just a little technique to make this hopefully a little bit easier. But go ahead and handle the first two like this. So we're going to FOIL or distribute, whatever you like to call it. We have x squared. Then we have 2x plus 3x plus 6. Combine those like terms, and we have x squared plus 5x plus 6. We still need to multiply that by x minus 2. Okay, now let's go ahead and deal with the x first. We're going to multiply everything over here by x. That gives us x to the power of 3 plus 5x squared plus 6x. And then rather than trying to write the rest over here, I like to just go ahead and put it below, right? And then you can just add vertically. So negative 2 times x squared, we'll line that up right here. You'd have negative 2x squared. And then negative 2 times 5x would give me negative 10x. And then lastly, negative 2 times a positive 6 gives me negative 12. Since I have my terms all lined up, I can just add vertically, and I come up with x cubed plus 3x squared minus 4x minus 12. So there is our polynomial. Okay, thanks for watching, and I will see you in class.